All right, ladies and gentlemen, in this class, I've got my class now, my favourite Year 10 class, and we're going to be going through unions and intersections today. Okay, so when you're studying for your test and you're going to have two-way tables and you're also going to have these Venn diagrams, so that's what we're going to be having a look at. You revise for your test. You okay there, Josh? Or all good? So we're going to be looking at constructing Venn diagrams and two-way tables and looking at how they are very similar or virtually identical. You have a choice. You can either go a two-way table, you can go a Venn diagram. Sometimes you'll be given a Venn diagram and you'll have to fill those in. A couple of things. If you've got a sample space, you'll see these things. Does anyone know what this symbol is? This symbol. It's also a name of a watch. Omega. Yeah, ohms. Yep, omega. That comes from the Greek alphabet. That can actually represent a set, okay, or a universal set. You'll also see this one here, which basically refers to the universal set or all of the different things in a sample space. We'll talk about that in a second. Then you have what we call subsets. So, for example, A could be a subset of my universal set. For example, if we look at the numbers between 1 and 20, then A could be, let's say, the odd numbers. And A, the odd numbers, would be a subset of the numbers from 1 to 20. Okay, so what we could say is that if I had the multiples of 3 under 20, then we could say that certainly that A is a subset of whatever you want to use for your universal set. Often you sort of have this, it's quite hard to draw, okay? I'll never really get you to do that sort of thing, but it's still nice to know. Okay, we also talked about complement yesterday. Remember, we talked about complement spelled differently, not the same spelling as complement. And of course, the complement of A dash is, well, it's not A. So if we're having a look at all the positive integers between up until including 20, and we're looking at A is the multiples of 3. Okay, so what would be not A in this set? Let's have a look and let's fill those in together. What would be not A? Yeah. Yep, so Josh is saying 1. What else is there? 2, he's saying 2. And anything that's not A would be, so we're looking at what, 4 and 5, 7, that's right, 8, 10, 11, 13, 14, 16, 17, 14, 16, 17, 19 and 20. Yeah, does that make sense? Now, we use these little squiggly brackets as well to sort of represent sets. So the set of A has the elements, okay, 3, 6, 9, 12, 15, 18. These are elements of that set. Okay, A is a subset of everything. All right, the same, of course, is not A, is a subset of everything. So what we're talking about is that 6 here is an element of A. All right, we refer to this here refers to this as an element of A. That is an element of A. Note though that the cardinal number of A is different. The cardinal number, how many different elements of A do we have? How many different elements of A? Let's have a look at how many different elements of A. How many different elements of A? How many different things do we have? 6. So what would be the cardinal number of A? 6. Okay, there are 6 things in A. Okay, you really have to be careful because, when I wrote these notes, I told you, I've put this in highlight. What have I said? Please take care when answering questions. Try not to confuse the number of A with the probability of A. A lot of people do that. We ask you for the cardinal number of A. How many elements are in A? That is just how many things are in A. There are 6 elements in A. So the cardinal number of A is 6. Okay? So the probability of A and the cardinal number of A are 2 different things. All right, so that's why I've highlighted that there. That's something that you really should take note of, and when you're revising, you should really revise over that because it's really important. It's a common mistake. A null or empty set can be referred to as a null set. Okay, that could be referred to as null set. And are we going to ask you too many questions, do you think, where we've got nothing in there? Probably not. Okay, but it's still nice to know. Are there any questions so far? All right, now let's get into the meat of it, unions and intersections. Now, I was talking about yesterday, like, how do we remember these things? A and B, A or B. Well, there's a few different ways. For starters, if I wanted to turn, this is A and B, I could turn that into a little A for and. Can you see that? Yeah, so if you wanted to, I could turn that into, there's another way of remembering it, A and B. And this one, I guess, we could turn this into an O, and we could make that A or B if you like. Another way I sort of said that, you know, if you were quite a let's say greedy sort of person, and you were sort of having on your Christmas wish list, as I said, I want a PlayStation and an Xbox, then you're not a very happy sort of person. So that's why I have sort of done this, A and B. Up to you how you think about it though. This is also the intersection. So you can see there, can you see there that A and B, we're only satisfied here. Yeah, we can see that it's the intersection of both those two. A or B is, we're satisfied with A, we're also satisfied with B. So that shaded region there is A or B. Okay, so this here refers to our intersection. A intersection B, A and B, like so. A or B, as you can see, we're happy it's that blue section there. Two sets are mutually exclusive if there is no intersection, okay? So if there's no overlap, then they're mutually exclusive. So what we could say is that A intersection B, in this case, is null. All right? Okay, now let's go for an example. Now this way we've got a Venn diagram and a two-way table. Let's start with a Venn diagram, all right? And by the way, we can turn a two-way table, we can turn this two-way table into a Venn diagram. You have the choice, but some questions you might be given this and we've got to turn it into a Venn diagram. Okay, now let's have a look. We've got English and maths. Now, if you like English, then that's obviously the E on the right-hand side. If you like maths, then that's on the left-hand side. If you like both, so for example, if I like English and like maths, where's this 28 going to go? The middle, okay, the middle. All right, so I'll get you to fill that in as you go, please. All right, quite a few students, I don't see pens moving. Now, if you like English and like maths, here's the thing though, as far as if I call M for maths and E for English, all right, that would be, by the way, how would we write this in terms of intersections? Well, we would say that's M intersection E. Does that make sense? All right, and I'll show you why it gets a bit confusing in a moment, because what about, now we've got a total of 61 people like English. Yeah, you can see there, over there on the right-hand side, 61 people like English. All right, so how many people like English but don't like maths? 61 people like English altogether. How many of those people don't like maths? 33, that's right, okay. So can you see there that 33, if I get my little highlighter out, okay, if I get my little highlighter out, these things, when I add them together, must all add to the same, to 61. Does that make sense? Okay, now, as you can see, by filling that in, we can then go ahead and fill in as much of these columns and rows as we can. Now, we can see that 33 people don't like maths and like English. By the way, let's give this a bit of a name in terms of maths. They like English and, just let's think about the words here, they like English and they don't like maths. Let's look over here. Where do you think that 33 would go? Inside the E? Yep, so 33 goes in here. All right, now I'm going to write this down. This, by the way, this is where people get a bit confused. They like, they like English. We'll do English first. We'll say that they like English and intersection, they don't like maths. Would we write M here? Or what's M complement? Yes. Does that make sense? Hopefully. So that there is E and not M. All right, and that goes there. This is the same for all of these. Once you do one in a few, you'll get the same. So if we have a look at those that don't like maths and they don't like English, where do you think that would be? Where do you think that would be? They don't like maths and they don't like English. There's 34 people that don't like any of them. It'll be the outside. Good. So 34 people, they don't like either. It can't be in either of those. So how would we write that as a set of intersections or unions? Yeah. Yep, absolutely. You could sort of say that they maths and English, they don't like maths. They don't like English, like so. Yeah. Or we could even, there's other things we could write as well. We could say that union maths and English, and it's not that. There's quite a few things. But let's just stick to intersections. Not M and not E is that the thing there. The cardinal number of that is 34. The cardinal number of E, English, and not maths is 33. The cardinal number of maths and English is 28. And finally, we've got here, how many don't like English? Well, how many go in here? 5, yeah, okay. Now, that 5 there, so that goes in there, yeah? I'm not sure. Yes, 39 over there. Yes, that's 39. And then 67, absolutely. Very good. Okay, so guess what? We have just done our first two-way table, which, by the way, is it's the same thing as a Venn diagram. I personally like to do a lot of things in two-way tables, and then Venn diagram is exactly the same thing. It's just in disguise. Okay, so someone tell me, now bear in mind here that people could like maths and they could like English, or they could like maths and not like English. Can you tell me, first of all, what is the probability of maths? What is the probability of maths? I might get my highlighter out here. Okay, 33 people like maths out of how many? 100. Yeah. It's not a third because the third is 33.33333. So in maths we want to be, so let's do this. The probability is the total number of favourable outcomes, which we talked about yesterday, which is 33, and that's over 100. You know what? Leave it like that. That's fine. If you want to say 33%, go for it. All right? Now, it gets a bit confusing there. What's the probability of not English? Well, you know what? Don't like English. Why don't we get this column? 39. Yeah, if you fill out the thing properly, then it's really straightforward, isn't it? Now, what about the probability of English and maths, the intersection? No, English and maths. So it has to be, they have to like English and they have to like maths. 28 is correct. Yes. 28 out of 100. Because the intersection of they like English and they like maths is in there, buddy. Yeah, look, absolutely. You can simplify all of these things. We know hopefully that 4 will go into 28 and 4 will go into 100. 7 over 25. Well, 7's a prime number, so we can't go any further than that. That's fine. That's fine. I do think you should simplify your fractions, absolutely. Get in the habit of that. We'll get there, we'll get there. Okay, now, are there any questions about all this? Okay, I'm going to pause this here because what I'm going to do is I would like you to try this one now based on what we've just done. Okay, hit the point, go. All right, now that we've actually done this together, first of all, you can see that everything, everything that's in the set is this E, 1 to 10. All right, use the squiggly brackets because they're the elements. Everything in the universal set. Of that, we've established that 1, 3, 5, 7, 9 are elements of A. A is obviously a subset of everything, so that's what I was talking about, subsets. A is a subset of everything, all right? B, to some degree, B is also a subset of everything. Now, we've also worked out that what is A and B? Well, what do they share in common? Okay, and you can see there that if I list the elements of A and B, well, as you can see, they share, sorry, my bad, they share 3, 5, and 7. Okay, so let's rub that out. Okay, they share 3, 5, and 7. All right, so 3, 5, and 7 is A and B. All right, A or B is, of course, everything inclusive, and of course, we didn't include 1 or 2, so 1, 2, 3, 5, 7, 9. And we also talked about anything that's not A. Anything that's not A is 2, 4, 6, 8, 10. And of course, some of those will go into a B potentially. And the cardinal number of A is 5. There's 5 things. There's 5 things in A. Okay, now that we've got that, we should be able to go ahead and fill in our Venn diagram. Okay, so first of all, I'm looking at things which are A. Well, we've got 1, 3, 5, 7, and 9, but 3, 5, and 7, let's talk about that. 3, 5, and 7 go in here, don't they? Okay, and the things that are A but not B, all right, I might even call it this, A and not B, all right, A and not B are clearly 1 and 9. Is that correct? Is that what you got? Okay, now over here, we've got B and not A. Okay, what is B and not A? Yeah, 2. Is there anything else? No. Okay, what about, and here's another one. This one over here, this blank void space, which is not in those, it's not A and not B. Okay, if you get your head around this sort of notation, it helps you so much. It really does. This is really important stuff because if you can understand this, everything from here is going to all sort of fall into place. So what is not A and not B? So 4, 6, and 8. You agree? Yep. So 4, 6, and 8. I'll put it outside of here. Here's 4. Here's 6. Here's 8. Together, when I bring all of that together, is that the universal? Oh, there's 10 as well. Very good. All right, good. Now, what is the probability of A? What is the probability of A? How many of these things are A? It's 5 out of 10, which of course we know is a half. Yeah? Now, the probability of A or B, if I get my little highlighter out, well, thank you. 4. There you go. How many of those things we're looking at 6 out of 10, isn't it? Does that make sense? Okay, 6 out of 10. We're cool with that, or I guess technically it's 3/5 if you like. Okay, let's get into the habit of simplifying them. Okay, and probability of A and B, 3 out of 10. Yeah, perfect. Okay, is it making a bit more sense? Yeah? Okay, now I'm going to pause this. I would like you to try this one now. All right? Okay, so just quickly, I'm going to go through these things here. The elements we're looking at, A and B. These are cardinal numbers. Okay, so the probability of A, we're looking for everything inside of here. This also is A. It's also B as well, the 1. So the probability of A is 3 out of 12, which of course we know is 1/4. The number that's not B. Okay, so the number is not B. Well, we all of this big circle on the right is B. So that means that we can't include that big circle, and I'm trying to rub out here, but I'm not having much luck. Okay, so the stuff that's there, we're looking at, you can see here, now my pen is doing all sorts of things. There we go, pen's back again. All right, so we're looking for that. That's not B. There's 2 things there, and there's also 3 there. All right, so that's going to be 5. That's the cardinal number of things that are not B. Okay, 5. The probability of A or B is everything inside those 2 circles. 7, that's 9 out of 12. Okay, 9 out of 12, which of course is 3/4. All right, and how many elements are in A and B? Just 1. Okay, we're just looking at 1 element. That's all we're looking for, the cardinal number. What is A but not B? What is A and not B? Yeah, 2, and we've got 2 out of how many things altogether? How many outcomes? 12. So it's 2 things. We're looking at this thing here. 2 out of a total of 12, which of course is 1/6, isn't it? Yeah. And finally, this is where it gets a bit confusing. The number of things which are not A and B. What is not A, but it is B? Yeah, it's 6. That's right. So there you go. This thing here is not A, intersection B. There's 6 things. We're looking for the cardinal number of that, which is just simply 6. If I was asked for the probability, it'd be 6 out of 12. Okay, now that's done. Unions and intersections. We can do 2-way tables. We can do Venn diagrams. Venn diagrams and 2-way tables are exactly the same thing. So therefore, this is really important. I think that I believe that you really should copy that down or at least cut it up and go into your books. Okay? That is what we've been through today. Okay? When we have a work lesson next lesson, what we're going to do is you do these ones first. Okay, you go ahead, and because they're different style of questions, then you backtrack. All right? Okay, by the way, we're done. Thank you.